All right. Hello, everybody. Hello, and welcome to the Michigan Flight Museum. So as you've noticed, we got a nice upgrade. I just got a last-second tutorial like 3 hours ago. So we're very excited for this, and we're very thankful that you guys came out today for this evening's program with all the crazy weather and with all the crazy DTE trucks in our parking lot. So I wanted to say thank you. My name is Becca Folsom, so I am the coordinator of these monthly programs here at the museum, in addition to the membership manager here. If you have any questions, you can always let me know. I do have a couple of announcements about the museum and our upcoming events before we get started for tonight's program. If you are on our e-blast list, you should have gotten an email too, actually, earlier this week about our membership swap that's happening this month. So if you have any kids or grandkids, the Impression 5 Science Center out in Lansing is a really, really cool museum. With your membership card, you can get in for free for the month of April. So I would highly recommend checking that out. And if you are on our events calendar, you'll notice that we're working with the Great Lakes Museum in Toledo next month. And they have 2 ships that you are able to walk through. And their summer season starts conveniently in May. So I would definitely go check that out. It's a really, really cool museum. If you are aware of other upcoming events, we have our 7th annual Bombers, Berries, and Brews event happening this Saturday. So it's a wine and tasting event amidst all of our static aircraft in the museum. We only have like a select amount of tickets left still, so I would highly recommend purchasing tickets on the website if you haven't already and you're interested in attending. That is happening from 5 to 8 this Saturday. And last but not least, one of our biggest fundraisers of the year, Thunder Over Michigan. That will be happening June 20th through 22nd here at Willow Run. There's 3 days of shows, so I highly recommend checking out the website, thunderovermichigan.org for those tickets. As members, you can redeem 30% off the tailgate pass, and if you have any questions or need that discount code, please let me know and I'll be happy to help you. We have historic presentation nights like this every Wednesday, first Wednesday of each month, with the exception of January. You can check out our upcoming schedule. I'll be posting the rest of 2025's programs on the event calendar. Hopefully within the next couple of weeks, everything will be up there. So you can mark your calendars for the ones that you're interested in. Lastly, before I introduce tonight's speaker, Tom Carroll, our volunteer coordinator, does mention that he has some interest, or he needs more people to help out in our hangar as mechanics. So if you are interested, you don't even necessarily need any experience. We have people that are there to help you. We would love your time and your talent if you are interested in helping us out. His email address is super simple, and you can learn more on the website as well. But volunteers at MI Flight Museum will get you through the door and more information from Tom. I'd like everybody to silence their phones if you have them on you, because we are about to do our presentation this evening from Rick Foltman, who is a meteorologist, very convenient for tonight's weather tonight, and retired from DTE as well, right? Yeah, so very convenient. We got the trucks up there and everything. So he will be talking about weather and its impact on aviation, and we're very excited for him to be here, so thank you. All right, it is all you. All right, here's this.
Thank you very much.
Yeah, thank you.
Thank you very much, everybody, for coming out tonight. Even though the weather isn't as nice and sunny as they like to be, then everybody else will be doing other things too. So they did not give me a welcome with all the trucks out there or whatever. I probably just kind of slid past and they didn't know who I was. But we'll talk a little bit more about that as we get along. So we can talk a little bit about the nice weather. I mean, this is a nice shot on the Lake Superior side of things. It's like light winds, maybe some high clouds. Maybe that's, I don't know if that's actually some aurora borealis or not. So looks like a good visual kind of day out there.
Isn't that red sky?
Red sky, yeah, I don't know if it's morning or night at that point in time, yeah. But now it's like, well, right here, right now, from the perspective of the camera, it's like, well, that's not too bad, you know, but if I was going that direction, I might be a little bit concerned about what is or isn't going on. We could be looking at 30, 40,000 foot, you know, tops going on. Probably a lot of up and down motion, updrafts, downdrafts kind of thing. It's one of those situations that, well, can I wait it out? If it's coming towards me, just do that, wait it out kind of thing. So I just want to go through and talk a little bit about weather. We'll have some opportunity for questions as we get along. But weather is one of those topics that whether or not you're a pilot or a driver or a student or father, mother, or whatever, affects everybody in one way, shape, or form. If you're at home, maybe it's just kind of a low impact. Going for a walk, you know, not a big deal. Driving, well, in Michigan it can be a little bit more of an impact, but then the weather kind of throws in a little bit of a problem there. Eating, well, hey, eating doesn't affect me, but if you think about it, it's like, well, if they're getting rain and the crops are growing, well, maybe that's a good thing. So it kind of affect a lot of our habits as far as foods and that kind of stuff. Boating, well, on a typical day like we saw in Lake Superior, may not be a bad day. But flying, it can be a good day, but then it can change very quickly. And that's one of the things that I just wanted to kind of throw out there and kind of emphasize by the time I'm all done. Weather is one of those things that's extremely dynamic, always changing, and that's one of the things that I liked about getting into the weather. Was that it is just that, it's always changing. And it makes it a little bit of a challenge sometimes as far as being a little bit unpredictable. It doesn't necessarily make it any easier as far as trying to keep a job, but flying, because of the physics of flight, is something that's very, very critical to know about what's going on with the weather. So I came up with, across this a while back, and a cartoon from BC. You know, Johnny, you only got half your answers right on your test. No problem, Teach, he says. Well, how can you say that? I'm going to be a meteorologist. Well, in my time working with DTE, that was kind of my nickname in some areas, Mr. 50-50. But I kind of figured, based on that, in baseball terms, it's Hall of Fame material. So it's like if you're batting 500, you're doing good. But so what brings me here? Well, I have a passion for the weather. I'm a weather geek. I think Becca mentioned that she was. I think that's something that's always changing, always something just a little bit different. And I tried to learn as much as I could along the way. And I like to share some of that stuff. So my last group of people that I talked to 3 groups of 3rd graders. So I kind of kept it a little bit basic for them, and maybe I'll get a little bit non-basic with this group. But it affects everybody. And I'd like to be able to at least share not only the passion that I have, but just the fact that it is so, different. It's dynamic. It's non-linear. We kind of think that everything goes, this way or straight, but the weather doesn't do that kind of thing. It's very, very complex. So I spent a few years at the University of Michigan, and then went into Detroit Edison, and I was there until 2022. So I transitioned from what would be the engineering research department, more air quality type things. And then in 1991, we had what we call a derecho came across the state. 60, 70 miles an hour, winds, and it's like, well, we have to do a report for the Public Service Commission. I was like, who could do that? Well, maybe we have a meteorologist in the company. So I was involved with that, and then in 1992, I had an offer to go to Consumers, but I ended up staying with Detroit, being that they offered to have me, as a meteorologist, doing weather. You know, who would think that a meteorologist would do weather? So that's where we started getting involved, kind of developing what does weather mean to an electric utility. So that's kind of where I went. So where do we go from here? We'll touch with a little bit of the basics. We'll talk a little bit about observing, monitoring the weather, a little bit about predicting and forecasting it, and then just living cautiously, safely with the weather. So in the big picture, this is what we're dealing with. We've got a big blue marble that has all kinds of things going on, and clouds and weather, and well, let's see, I think the world is covered by like 70% water. So that's one of those things that's like, well, we got to take that into account when we're predicting the weather. And there's always something going on. And obviously you can see certain patterns. Certain areas are brown, certain areas are green, certain areas are blue. Well, that's probably the weather patterns, the climate, basically changes, but those areas are pretty consistent across. So we talk about, weather. How do we go through and characterize it? Everybody in this room is probably going to have a little bit different aspect as far as how they've dealt with weather in the past, or where they live. Just, big difference right there. So monitoring the weather takes standards. It takes some good equipment. Wind vanes are good for maybe a particular house, a particular farm. Monitoring the weather means we've got to be accurate. One person says, well, I'm going to use the Canadian system. Another says, well, I'm going to use the international system. Another says, well, I'm going to use the English system. Well, what units are we going to use? We have to be consistently and we have to be accurate with what we're doing. If I'm talking everything in centigrade or Celsius, and somebody says, well, what's that mean? We got to be consistent with, are we going to be Fahrenheit in the United States? Well, that's something that most people recognize. Then we got to share the information too. Well, we got to make sure that the information, we know where it came from. If we're going to share it appropriately, well, you want to make sure that it's reliable and we can communicate it appropriately. And those are some of the things that kind of happened over the years, because weather is, just like I said before, it's very complex, very dynamic, and requires a lot of data. How do we monitor the weather accurately? Well, we use equipment, anemometer, and then we can turn around and say, okay, let's share that. Okay. Speeds are good. The wind direction, we may need to do that. We may not necessarily want to use it if there's a hawk or something sitting out there. But at the same time, it helps to know which runways we're taking off of, which direction are we going to. And those are all good pieces of information that we need to know. And then we say, okay, that's great, Rick. What about going on 5, 10, 15, 20,000 feet up? It makes a big, big difference. So we have to relate to that stuff. Well, first of all, if we're going to capture all that data, we're going to analyze it, we got to share it. So the Weather Service, and over the years, had to come up with different ways of sharing the information, interpreting the information. High pressure, fair weather. Low pressure, maybe not as fair. Maybe there's something going on with some converging winds, or maybe some rain or something like that. So that's great, but hey, the weather's going to change. In 15 minutes, we could turn around and have wholly different conditions going on. So we got to make sure that we have that information. So looking at levels above the ground, the Weather Service ends up using weather balloons. So what they do is, at 0Z and 12Z, they send up a balloon like you would see here. They would, some cases, use hydrogen, some cases use helium. It would have a parachute on it, and it would end up having a radiosonde, a weather package hanging from the below. And as that's going up into the air, it's radioing information back to the ground. What's the temperature? What's the dew point? And then they track the balloon and say, oh, okay, it's going this direction at this speed based on how far the balloon is moving and how fast. So that information is collected at about 160 or so places across the United States. In the world, it's closer to like 1,000 different places, and all that information has to be fed back in to the different weather systems, weather bureaus, in order to go through and interpret it. This is kind of what you might expect to see. This is from DTX, which is the one where they released them nearest to us, and that's up in White Lake. So this is the temperature, the little red line on the right, and then the green line is the dew point, the amount of moisture. But then you also get the winds. And then over the years, they've been able to go through and say, okay, well, based on this kind of a sounding, give you an estimate of what's going on with the amount of moisture in the air. Well, if the temperature and the dew point are close to each other, you'd expect more moisture to be in there. So in a sounding like this, you might turn around and expect, okay, maybe it's not a lot of precipitation going on, maybe none at all, because they would probably be very close to each other. And then as you get aloft, you would end up getting conditions that would be, probably drier. That's why if anybody's flown before, once you get above a certain level, hey, it's nice up here, but down below, it's, raining. Well, that's why we've reached the top of the clouds. So these are the kind of things that are done at all kinds of different locations. Michigan used to have 3 places, and then when they reorganized the National Weather Service, they're down to 2 places now, and that's in White Lake, and then up in near Gaylord, up at AVX is the site they call it up there. So then they'll take all that information, and they'll turn around and plot it up on maps. So now you've got radio sound locations across the world, in the case of the Midwest. Then you can get an idea as far as, okay, what's going on with the winds, and then the temperatures. And so this would say, okay, this is where we get the concepts of the jet stream. We end up seeing, oh, the wind is highest in this corridor. In this case, you probably see the winds following the line that you see here. These would be like iso height lines, not necessarily isobars. You might have heard pressure lines, isobars. And you'd end up seeing the wind follow that. Well, in this particular pattern, this was March 9th. And I think we end up in a little bit of a cool spell. So if it's cooler to the north in Canada, warmer to the south, you're probably getting some cool air coming across the Great Lakes, maybe having some lake effect snow. Down south, you're getting don't have those effects lasting out. And over the Great Basin, maybe you're getting some drier weather because it's high pressure at that level. This would be I think 10,000 feet. So some places will turn around and say, okay, let's colorize those kind of things and make it a little bit easier. So they take all the data and they would interpret it to get something like higher winds in this particular area. So if you were flying from the west coast to the east coast, and you follow a certain, patterns, let's see, what level is that? You could definitely turn around and end up seeing that, okay, it'd be a little bit quicker going from west to east than it would be from east to west. Or if you're going from east to west, maybe you want to avoid some of the places where the winds are highest. So that's one way of looking at what's going on with the weather at different levels than kind of like at the ground. But so can we use like satellites, to monitor all the weather that's going on out there? Well, that's good to a point, but in essence, it's good. Gives you a great picture sometimes, but we can't do it all even with satellites because you end up getting cases where, well, by the time you're looking further up down to the surface, you have a lot of different layers to go through. At higher levels, may be dry. At lower levels, may be wet. In the case like this, you've got a lot going on in the Great Lakes. You have, some drier weather in places, but you may have some fog. And then how do you tell a satellite to go through and say, well, this is a high cloud or this is a low cloud? So there's a lot going on. Most cases, these are probably lower clouds, coming off the lakes based on certain weather patterns. what's nice about the visible pictures, and you can see back into Canada and Minnesota there's actually white on the ground. Well, that probably indicates they have snow on the ground. That this was back in February, and even up north and lower. Well, if you can look through the clouds, look at the gaps, there's white on the ground, so there's probably good indications that there's some snow on the ground still. So they have been able to go through and use satellite imagery, and then they have some new equipment that they can detect lightning from the satellites too, and this would be a case where you could see something like that going on. It doesn't give you the precise location where the lightning might be hitting, but it does give you an idea of, hey, in that particular band of clouds, is there something going on? Is it more convective in nature? So I've got the little cartoon here. It's fantastic. I can find out the exact weather outside this exact house at the exact moment, all on the internet. Well, everybody has an app. Everybody has a favorite app. But nothing really replaces an observer or a pilot or a spotter or a boater or a camper or somebody that's outside to really see what actually is going on. And that's why I'd like to emphasize that's really important. Spotters help the National Weather Service out quite a bit to be able to relay information about a storm coming in, because a particular storm may only hit a square mile. And if there's nothing going on and they don't have any reports, how do you go back and get that information? So everybody has to be, in my eyes, a little bit aware of what's going on. So we always see on our weather apps, weather radar. Well, is that the ticket? We talked about satellites and sensors and that kind of thing. Well, because we live on a nice round planet, there's a nice little curvature there. So when the radar is sending out a radar beam, use this as an example, Grand Rapids and Detroit, those beams go straight out at different levels. Well, what about in between there? They're not at the same height as you might expect as they are at the radar sites. So somebody may be actually in between. So that's another reason why we kind of need to have some spotters or weather equipment to say, well, what is actually going on in between there? The radar does a good job picking up things, but at the same time, it is not the answer for all of our weather needs. And then sometimes certain weather apps will just say, oh, we'll just kind of go through and combine all these radar sites together. It's like, well, wait a minute, you're cutting out some of the most important information because the radar works in several different modes. It works in a clear air mode on a nice clear day, which is not as sensitive, or it's just very more sensitive because it's trying to pick up little things going on. A precipitation mode on a day like today, but then later on, if there's some storms coming in, well, they may be wanting to switch over to severe weather mode. So all these are updating a little bit faster to get an idea of what is or isn't going on, not to mention the levels that are being observed. So this is a snapshot of the radar out of White Lake. And there is a difference in every radar site. So we're not seeing anything from Grand Rapids, but it is nice to know that there is another radar site that's closer to Metro Airport at DTW. And that's what they call a terminal Doppler radar, where you can see just what's going on. And the reason they put terminal Doppler radars in there because they can turn around and be not as big of an area to look at, but they can look at what's going on at the airport, primarily for wind shear. So that way they can get an idea of what's going on. So this would be just another little band of rain, some thunder, kind of coming through. This was October of 2020. This is off of a site that I like to use. It is a pay site for a little under $100 a year, called Weather Tap, out of Tennessee. This is off of a different site, and they're going to be looking at weather information from different locations, and then also they include some of the what they call AWOS, which is the Air Services, Air Weather Observation Systems. Some of them are at airports. Some of them are run by the Department of Transportation to give an idea of what's going on. Sometimes you gotta look at the data with just a little bit of a grain of salt to say, okay, why is on one side of the highway, the wind's out of the west, and sometimes the winds are out of the east? It's like, well, or why is one showing 50 miles an hour and one saying 5 miles per hour? Well, is there something going on, thunderstorm? Is it good data at that point in time? It would be nice to have weather data like every square mile. Well, we don't have that kind of ability. Even if people have, their own little personal weather stations at their house, I mean, that's a step in the right direction, but is that information getting out to people that could use it? And is there a house nearby? If somebody's looking at the temperature, it's like, well, is the temperature sensor near a chimney? Well, that's not a good thing to do either. Or are you getting a real good wind flow? I mean, out here, Willow Run, you're much more open. You get much better wind blowing through, and you can also monitor that much better. One thing that the radar will give you is the vertical wind, and which is nice to look at too, because now it's broken up into different levels, every 1,000 feet, going up to, in this case, about 28,000 feet. And all the little triangles, well, if you're familiar with that, each one of those above is 50 knots. So then it's kind of like, oh, okay. Once we get above 10,000 feet, we could see 50 knot winds at that point in time. Down below that, we see a little bit wind direction change, but the winds are not quite as high. And then it's also giving us an idea as far as going back in time, what those winds were like going back. In this case, I think it's about an hour or so. But this is one aspect that's just over the radar that kind of gives you an idea what's going on with the winds. So we've seen a little bit about how the different aspects of the radar and the satellite, but then how do we deal with all the variation in the weather? In this case, this is the highs and lows at Detroit Metro. It's measured at a standard of 2 meters for the whole year. Well, the bottom line, the pink, is the low temperatures and how it varies. And on the top is, well, the red line is the normal. The light blue line is the normal low. This is the normal high. And then the dark blue is the variation in the actual high temperatures. Well, how do we go through and figure all this out to be able to go through and characterize this and use it as a tool to either predict things? Well, the one thing that stands out to me is it's colder in the winter and warmer in the summer. That's kind of obvious. But at the same time, sometimes the meteorologists have to go back to the silly things, or the things that are pretty obvious, to say, okay, was it really cold this January? Well, it looks like because everything was below the normal, or the normal here in this case is probably 30 years worth of data. And then the high temperatures didn't go much above the normal high. It was probably a cold period of time. But then at the same time, in the summertime, you see that too. It's like, well, wait a minute, it wasn't that really hot of a summer at that point in time, because the blue lines didn't get too high above the normal lines. So when we talk about the normals, so many times the National Weather Service uses a rolling 30-year time period. But you kind of have to watch, because somebody may talk about, oh, well, this is higher than average, higher than normal. But what are they using? If it was only the last 5 years, how do we really know that? Is that a long enough time period? If we're talking about 100 years, well, hey, that's why we have records. Record high temperature, record low temperature. I didn't plot that up on this one, but the record highs, would probably be up closer to 100 in the summertime. Makes a big difference is how the perspective is, how you look at the data. The same would be true looking at the wind speeds. It's like every minute on this chart, you're getting a new wind speed. Okay, well, where's the wind gust on here? Or what's the wind average on here? So it's hard to go through and characterize it. Well, we all can step outside and say, man, that was a really, really strong wind. Well, it was a high wind gust. Well, where does it fall onto a chart like this? We have to be able to characterize all that stuff and share that information to be able to, to go back and say, okay, what works on a digital basis? Can we look at these things on an analog basis? And what works best for sharing and characterize, what was actually going on in that particular area. One example that I like to kind of show here too is that we've all heard about, hurricane predictions. Hurricanes coming into here. Well, this is an example of Hurricane Irma back in 2017. Well, all the little lines on the top graph were different predictions made on a particular day of where that storm was going. Well, some will say, well, no, I used this model, or I used the European model, or I used the American model. Okay, which one was right? Well, it looks like, based on the actual conditions here, it moved to the western side of Florida and not the eastern side of Florida as predicted here. So we have a lot that have to deal with in meteorology as far as figuring out what kind of gaps we have, little deficiencies. And so we'll go through and analyze the data, interpret the data, interpolate the data from more places we don't have data. An example might be, well, how do we get the winds out in the middle of Lake Michigan? Well, there are a couple of buoys out in Lake Michigan, but is that representative of the whole lake? So there's a lot of little things where you interpolate the data, some places where you may smooth the data out, but then again, if there's a thunderstorm or something going on, are you smoothing out good data points? There's a lot of different things that the Weather Service has to go through and take into account. So they may use different types of models, ensembles, deterministic models, stochastic models. They use the basics that you learn in school, the law of thermodynamics, conservation laws. You can't create something out of nothing. And the motion laws. Well, then they come up with even better quasi-geostrophic omega equation. There's all kinds of different things going on, and then you go through and interpret the values. So they may turn around and say, okay, the weather for Belleville is what's represented at Willow Run Airport. Well, is that the same weather that would turn around and be available up in Canton or down south towards Monroe? But that's the way the models go through and interpret things. So you use certain very equations and the laws, but then again, just like we saw in the difference of hurricane paths, there's certain mathematical errors. And then it may take, years ago, it would take hours to go through and run all the models, because each one of these little cells on here shows, you would probably have one data point and one reference, and that one would interact the next one. So there's all these little computations that have to be made along the ways. And then at the same time, you might turn around and have to deal with, okay, communicate this, share this. Well, what's going to work for one person might be more visual oriented. Somebody else may say, well, show me the number. I just want to know what it's going to rain or not. So all these little different things have to be dealt with on things. But then the bottom line, a lot of this stuff is, by the time you go through the input and get some output, it's like garbage in, garbage out. If you've got bad data coming in, then you're going to get bad results coming out. So just as an example, I'll kind of run through this real quick. What they try to do is they take and interpret one data point, and some models okay, this particular model may use 1 kilometer square. This one may use 10 kilometers square. Well, then it's like, how does this square, this cube, impact the weather in the next one over? And then how does that affect what's going on up above? Well, using the satellites and using the radiosonde data, we may turn around and be pretty steady aloft, but there's all the stuff going on down below that makes it harder to go through. So then we have to take into account, well, what were the conditions? What were the water temperatures? What were the winds aloft? What about the last model run? Well, did the last model run work? And then, well, how often do we want to update the models? Well, some of the models, actually, they first started only outputting them like once every 12 hours. Well, we want more, we want better, so then they went down every 6 hours. And now you've got some models that are very localized, and maybe we'll get a chance to see a little bit here in a little bit, that are updated once an hour. So they take the previous information and the new data coming in, and then turn around and create a new model output. Then another thing that we have to deal with, we don't know that much about the weather like we think we do. We can look outside, oh, in the last couple of minutes it's been doing this. But how do we go through and talk about the last couple of days or hours or weeks? Well, we've only known, the one example is the El Nino. Everybody's heard about ENSO or El Nino, La Nina. We've only known since the late, 1980s or so that was even happening. So then they started putting some buoys out there. Well, just because this pattern is going on doesn't guarantee that we're going to have this kind of thing going on into the winter or going on into the summer, because we don't have all the data. Maybe there's some gaps because we didn't know what was going on at that point in time. And I guess the end result is that, okay, if we don't know what was going on in the past, it makes it very difficult to go through and make predictions, not only if our models are running, poorly, but also we don't know what's going to happen because so many things are automatically assumed. So some of the things that we don't know much about is the sun always a constant amount of energy putting it out? We don't necessarily know, well, we heard about the polar vortex in the wintertime. Is that something that's normal? Well, yeah, I mean, the weather does move around. We talked a little bit about El Nino, La Nina. It's like, well, those were weather patterns of the oceans, temperatures changing around. Water temperatures, like in the Great Lakes. Well, we know that in the wintertime, the lakes might freeze over a little bit. But the lake doesn't freeze solid, because as soon as the temperatures warm up and the ice breaks up, the lake turns over, and all your warm water ends up coming back up to the surface. So, I mean, all these little things that have to be taken into account. One thing that I didn't even put on here is we talk about clouds. Sometimes more clouds can make things cooler. Sometimes the type of clouds can make things just a little bit warmer. If you have high cirrus clouds, they might make things just a little bit warmer on the ground. But some of the weather models don't go through and even take into account all the different things that are going on with clouds, because they don't know, is this cloud more ice? Is this cloud more, water vapor? Because some of these little cells that we talked about, they automatically assume that, okay, this is like 80% chance of, or 80% humidity, because there's going to be a cloud there. It's like, well, how do they know that? Because sometimes the assumption may be wrong with everything going on. So, I'm going to come back now to a little bit of on the aviation side of things. On thunderstorms, we have to talk a lot about different things because they can be very localized. We may end up seeing a thunderstorm that maybe only affect 1 square mile, but then we may have one that may be hundreds of square miles, or a squall line moving through and impacting everybody. Not to mention the turbulence, the hail, possible tornadoes, wind shear, low visibility. Gosh, my gosh, fog and smoke. Certain times of the year we see a lot of fog. Well, why partly is that? Because the ground may be staying cold, and warm air is now moving in aloft and condensing out on that, in that cold surface, so we see more fog. Well, give it a chance and maybe it'll burn off by 10 o'clock or so once things do warm up. But it makes a big difference on how we deal with taking off, landing. Snow and ice, my gosh, we could probably talk hours about ice and snow and how it affects not just the aircraft, but your runways and the maintenance and the closures, and can you even get into an airport? A couple of Christmases ago, we were visiting the grandkids down in Texas, and we were the last flight out just before they shut down the airport at Metro. And it's kind of like just that close to having to wait. But it's a matter of, you got someplace to go as far as to land and park the plane, or can you even get off because they can only keep the airport open so long as far as keeping the runways clear, keeping the planes de-iced, that kind of thing. The jet streams, my gosh, that's, again, could be a whole nother class, just dealing with turbulence and the fuel consumption and flight delays and time variations. It's like nowadays, it's like, well, you can't get someplace and you got someplace to go to, and if it's like, well, if they're tied up, if they're fogged in, if they've got thunderstorms, well, you're going someplace else than where you intended to go. Tropical storms, hurricanes, that is a totally different thing that you have to turn around and avoid, and small planes will go around, or they may actually turn around and cancel everything. But in talking about thunderstorms and convection, the little dilemma I like to talk about, a little example I like to use, is the example of a garage. So if you had a garage that was full of gasoline vapors, my example here is gasoline vapors are like the moisture. The moisture is like the fuel for the air, for the thunderstorms. So if you turn around, if you've got three things when you need for a fire, you need a fuel, you need oxygen, and you need a spark. So if you turn around and open up this garage door, let all the gasoline vapors, let all the oxygen out, everything's fine. But if you close the garage door and supply a spark, you're not going to have a garage. It's going to be gone. A thunderstorm is very, very similar. You can have a lot of moisture. You can have a lot of instability. But if you don't have a trigger, if you don't have a spark, so, I mean, a lot of times we're waiting for that to happen. Is it a cold front moving through? Is it a trough coming through a loft? Is it even a little lake breeze front from Lake Michigan? Are you going to turn around and get something to trigger it? If you don't have the trigger, everything just goes through. It's like, well, the forecast was wrong then. It's like, well, we didn't, they're anticipating based on, their conditions, and if you don't get all the conditions to come together right, or move just a little further south, or a little further north, things aren't going to happen. So a lot can happen. And on the small scale, temperatures can vary in one place. Like today, I think, the forecast was supposed to get up into the low 60s. I think the last time I looked when I came in here, it was only in the 40s. So something was going on a little bit different with the weather there. Well, we had a lot of rain earlier. The rain may have cooled the air a little bit. Maybe the front kind of held in just a little bit. But with the system coming through, well, it could warm up. We could see a high temperature today, yet closer to midnight in low 60s. But then turn around and cool back down afterwards. But there's all these little different things that we that are hard to go through. And it makes it sound like I'm making excuses as a meteorologist. It's like, yeah, you worked all these years and you're just making excuses. Well, but that's the complexity, the dynamics of the weather. I mean, hot, dry conditions may seem like, oh, perfect time to go flying, but you don't have quite as much lift. And I remember hearing the cases down in Arizona out there, 110 degrees or something down there. And then it comes down to like, well, they're having issues with planes taking off. Well, the air was hot, it was dry, and not to mention some of those places have a little bit higher elevation, so it's like you don't have as much lift. And that's why so many people talk about in the wintertime it's so nice flying because the air is nice and stable, it's cold, you have a lot more density in that air, but it's just the opposite come summertime. So I'll talk just a little bit about the whole Earth and all the different drivers we have here. So we know that we live on a sphere, on the Earth, but all these little different things, the sun is heating things up. It's going to heat up and move things to the higher rises, cold air sinks. So you would think that, okay, that's going to happen. But there's all these other things that get in the way. The elevation, the chemistry as far as the amount of oxygen, nitrogen, water vapor in the air. We also talk so much about, ozone and carbon dioxide. All those things are players, but some are bigger than others. The water vapor is probably the biggest greenhouse gas that we have as compared to carbon dioxide. So the models can't even handle some of that kind of stuff. So now you take this planet and you say, well, okay, hot air rises, cool air sinks. So to the north, you're going to get a certain circulation, and then you get the jet stream in between the different patterns, and then it's like, okay, put it on the big planet. Well, when you bring the air together, that's where you get some convergence. So you get along the equator, you get a little bit more cloudiness, a little more rain. Those are the tropics. Same kind of thing happens up north in Canada at 60 degrees. Convergence, you get some things come together. And then you end up getting the drier air, the high pressure, and you get the westerlies. Well, it's kind of a little bit different picture. The intertropical convergence zone kind of goes through the Amazon, so they get a lot of rain. Sometimes that pattern shifts a little further north, and you get a certain pattern. Maybe you're kicking off some storms off Atlantic, bringing in a hurricane. And then they kind of follow some of the patterns. But all this stuff, and this is kind of like a snapshot, a generalized picture of things. But it's always changing. I mean, there's some general things going on, but at the same time, it's, and then let's throw in what's going on with the oceans. Well, then there's the Gulf Stream, and the warm water, heads north, and finally, cools off and heads back down to the south. And all these different things have to be factored into the weather models. And then we try to go through and say, okay, now let's talk about the winds at the surface, or the winds at 5,000 feet, or the winds at 18,000 feet. They're all just a little bit different, and they all impact what's going on. The one thing that I wanted to kind of throw in here, I go back, where I have MTN. Well, one of the reasons why there's no data there's mountains. Well, how do you go through and get data where there's mountains? Well, you don't. So the models have to take that into account too. We don't have 5,000 foot mountains in Michigan, but at the same time, it's kind of like, oh, okay, let's we have to go through and figure those things out. It's like all of a sudden, if the wind's going into a mountain, it can't go through it. It's got to go up and over it. So that's why sometimes you'll get weather systems developing, because now it went up and over the mountain. It may be wetter on one side but drier on the other side, but it may develop a weather system on the other side of that mountain. Okay, so some of the things we'll go back to this later on. Look at some live things going on. Storm Prediction Center, National Weather Service, NOAA, I should say, is one of the best sources of information. They are entitled, or not entitled. Their job is to do the weather for the country. So we don't have competing weather companies. They're the ones that issue all the watches. They're the ones that issue the warnings locally. they're the ones that have the responsibility to let us know what is or isn't going on. And that's the Storm Prediction Center. Then they also have some other branches of NOAA, the Weather Prediction Center, the National Weather Service, which has local offices where they have the radars at, send up the balloons. They have a Hurricane Prediction Center, they do tropical prediction. There's the Aviation Weather Center that deals just with the aviation aspects of it. And then there's also a space weather side of things. So every day, multiple times during the day, the Storm Prediction Center will issue convective outlooks where they would expect the possibility of some convection, thunderstorms, that kind of basic type stuff. Other areas, maybe just a general, not a big wide coverage, but so many times it's very, very important to know, okay, are we talking about severe weather or are we talking about just a general thunderstorm kind of thing? And the one thing that I also want to make sure that we're aware of is the timing. Timing is critical. We may see a blue sky morning, and by 10 o'clock we've reached the temperature where now the clouds are starting to pop up. Well, the ground has been heating up, the clouds are now forming, and then we reach the convective temperature, so now you're getting some clouds. And by the end of the day, late in the afternoon, now you're getting chance of thunderstorms. Well, it was blue sky earlier. It's all because of the heating of the sun, developing the convection and getting the chance of some showers or thunderstorms. So then the Weather Service will issue thunderstorm probabilities and that kind of thing. We'll look at the live stuff. One thing also, and you have to watch if there's something going on. If there's a thunderstorm watch, a lot could be going on. The one thing I wanted to show, this is that same radar picture we saw before. The whole system was moving off to the east, northeast. Well, sometimes you get a little line of convection, a line of thunderstorms out in front of where the actual front is going to be. And that's sometimes you have to watch even more so, because that's where you can see some development even before the cold front comes through. So that's like the first line on the right hand, and then the second line is where the actual front was. So there could be some development. A gust front, can kick off some strong winds with that line. May not necessarily be severe, but it may be enough to go through and cause us some problem. Thunderstorms can be very short duration. The average thunderstorm probably only lasts an hour, but then another one may develop right behind it, or off to the right or to the left. Afternoons are probably the best time for thunderstorms. And again, like I mentioned, we have to watch out for the gust fronts, some wind shear, hail, heavy rain, and occasionally, tornadoes. Sometimes we get something that conditions are just right, and it may be a little bit of rotation in the thunderstorm. It may not be enough to cause a tornado, but maybe enough to turn around and give you some high winds. And we've all heard a little bit about wind shear. The biggest concern here is that how do you adjust for the updrafts and the downdrafts of a thunderstorm? Sometimes you don't, it's not like it's a certain color, but if you see something developing like we saw in that very beginning, the thunderstorms, there's a lot of vertical motion going on there. And when you have a lot of vertical motion, what goes up must come down. One example that I've used, you talk about strong winds. Well, years ago, traveling across the Mackinac Bridge, if anybody's gone across the Mackinac Bridge, you're probably about 150 feet above the water surface. So you're up in the air a little ways. And if it's a real windy day, they may actually shut the bridge down these days. But you'll find yourself correcting your steering wheel so that you're not getting blown out of your lane. Well, then you get to the towers, and all of a sudden that wind isn't there. So now you're going through and you're correcting this way. Well, then you have to recorrect the other way. And then the wind comes back, and you've got to recorrect where you were going before. Well, that's kind of like doing the same kind of thing with flying a plane. you're trying to correct, you're trying to go through a normal landing pattern, or maybe taking off for that matter, but all of a sudden, you're getting more lift, and then you're getting less lift, and if you're not correcting things appropriately, then you can turn around and have some problems. The same is true with driving. You know, it's like you're correcting, and you're uncorrecting, and you're correcting again. Well, in the case of the corrections, there was a car that actually went off the Mackinac Bridge because of those kind of things. And I can understand why you've got a small car, you're correcting, and you're not familiar with the conditions, that kind of thing can happen. Fog, we'll just touch on that a little bit. You know, fog is basically moisture that's being condensed by changing local weather conditions. Well, there are a lot of different reasons we can have fog. We don't have too much of, fog situations related to oceans or the lakes a little bit around here. But all you've got to get is a little bit of a dip in the ground, valley fog in this case, and you may turn around and get a little bit of condensation of fog. But the good news is that it's going to probably burn off once the sun comes up and heats things up a little bit. A lot of times you'll be moving warm air over a colder surface, and then you get the same kind of thing. I'm originally from Escanaba, if you're familiar with the Upper Peninsula. Flying up there in the wintertime can be fascinating because now you're going through and you may be flying out of clouds, but then it may be clear skies on the Wisconsin side. Well, what happens is the cold air comes across, actually kind of creates a fog over there, and then the fog gets a little bit thicker, turns into clouds, and now you've got a case where on one side it's clear skies, on the other side you're getting a lake effect snow. So, I mean, just the little things like that in and around Michigan, it's kind of like fog, but it's not. Icing. Icing is just one of those situations where it's like, if at all, avoid, any kind of icing conditions. And in Michigan, that can be kind of touchy with the changing weather and a little bit sources of moisture on the lakes. But it's very very touchy because now with flying, you don't want to turn around and put yourself in jeopardy because of ice accumulation. There are some good products out there that talk about the icing conditions based on the geography, based on the elevation, and the amount of moisture that's out there. But it's very, very critical. And I guess one thing that I wanted to mention before was, just like on the sounding, it may be nice and warm on the ground, but as you go further north or further aloft, it's a lot colder aloft. And just the amount of moisture at certain points along that can make a big difference as far as whether or not it's going to be wet or if it's going to be sticking as a form of ice. Turbulence. We don't have to deal too much with mountains around here, thankfully, but there is turbulence going on simply because of other planes, other things going on. One of the things I had an opportunity when I was in school, our department ended up forecasting for the National Soaring and Sailing Competition down in Adrian. And it was one of the greatest things I've ever had an opportunity to do. So I got a chance to go up in a 2-seater sailplane. And so they pulled us up, and no engine, but you're up there, it's like you could just feel, you go over a parking lot, you could feel the plane lifting up. You'd go over some water or some trees, and you just kind of feel it mushing down. And the stall, stall speed on those is low, that you can just kind of, okay, well, we need to go find another thermal somewhere. We need to go find some other place, some bare ground where we can get a thermal picking things up. And it's kind of like, that's kind of like a very, very small variation of turbulence. But you get some upwards motion, you get some downwards motion. Well, then if you got thunderstorms going on, or you got some convection even before the thunderstorms, then it's where you can turned around and a lot more turbulence going on. And then one of the things that's really hard to do is find turbulence, because it's not like the sky turns a certain color, but that's why they have to try to use the weather models as best they can, or look at downstream from mountains and that kind of thing. One of the graphics that they produce as far as both modeling and reports of turbulence from the Aviation and Weather Center. One thing about tropical systems, in this case is back from 2018, tropical systems are not very tall. So you might be able to fly over something, but if you've got something that's obviously a little bit bigger. But if you've got something that's smaller, you want to avoid anything going on, because not only do you have heavy rains, but you've got some strong winds going on as far as with the tropical system. So I found a couple graphics online, and what I found was kind of interesting was that there's a fair amount of things that we can and can't do as far as either predicting things or aware of what's going on. Weather is, 22 to 40% or so of what is going on with, aviation, air carrier and general aviation, incidents. And obviously, we take care of the aircraft, but the rest is kind of like, okay, we got to take care of ourselves and know what we're getting into as far as weather-wise. In the summertime, it's just a tad easier because you don't have to deal with icing as much. But at the same time, it's like there's always something we got to be aware of. What I did find was this graphic too. Is like you hear a lot on TV here in the media talking about safety or incidents and that kind of thing. But what I like to see about here is that with the technology and people kind of thing, we can turn around and see that there is an improving trend going on with airplane safety. Other topics I'm not going to talk too much about. Local weather. I mentioned morning time is one of the best times. Light winds, not as much convection going on in the summertime, or even this time of year. Mesoscale is one of those things where it's like, oh, what's that, Rick? That's like local weather. I mean, the weather over certain areas, if there's not much going on what we would say on a big picture, synoptically, then there may be something going on locally, just along the lakes. There may be lake breezes. There may be some convection along the lakes. That's kind of like a mesoscale kind of thing. The geography. We don't have too many big things except for the lakes and the lands around the lakes. Space weather can affect communications, may affect other things going on out there. Volcanic ash, I've heard is an issue too, as far as they have to route flights around where there may be a plume of ash from a volcano, like up in Alaska. Mountain waves will kick off a lot of turbulence, and sometimes you'll see certain kind of weather patterns, you end up getting waves off of the lakes or off the mountains. So a few of the takeaways that I just wanted to kind of leave you with here before we talk about some real live weather. Be aware of local geographic influences, what I just mentioned, like on the mesoscale side of things. Expect the unexpected, be prepared, be aware, situational awareness, be educated. Use your gut, because sometimes that can be your best thing. You too can be a weather person. Some of the best forecasters, best weather people are not those with the highest grades, highest degrees, but they have the most experience, like in the Air Force. And I'll take that moment. Anybody that's put some time in the armed services, I want to thank you for your service along those lines too. A couple last things. If we can't really accurately forecast the weather over the next hours, days, next week, how can we expect to do it years in advance? I've heard that people that have services out there will tell you, when's a good day to have a wedding in 2027? It's like, well, good luck with that. But all weather models are based on math and physics that are pretty basics, but they're also very dependent upon the assumptions that go into them. And if you make assumptions and you leave off certain terms or make the wrong assumptions, that's going to affect the results of the models. So I found this, I thought it was kind of cute. First day as a pilot. Control tower says, "Can you give me your position?" Me, I'm next to a cloud. I said that. As I said there, that looks like a lion. The control tower says, "Can you be more specific?" Simba. So thank you, and we'll take a little bit. I can do questions if you want to do a little bit about the weather. Yes, sir.
Yeah, first, how big are weather balloons? What are they made of? And are they reusable?
Question is on the weather balloons. They inflate them. I think they can be as big as, well, they get bigger as they go higher up in elevation. I think they probably start about 10, 20 feet across. I think I don't know if they're Mylar or not. I think it's a type of latex rubber. And they get bigger as they go up in elevation as the pressure goes down. And I think I mentioned before that they either use helium or hydrogen. The balloons themselves will pop. The package has a parachute and will fall down. And they're smaller now. They used to be bigger, but they're maybe about that big. And has an address on them. And that part can be recycled and reused as far as electronics and such. Yeah, thank you.
So if someone finds it, they can mail it back.
You can mail it back, or if you find one, keep it as a collector's item. I don't know. I don't know. Obviously, you can change out the batteries. I don't know how much they reuse. It's our tax dollars at work, one way or the other.
Be interesting what percentage of them they get mailed back.
Yeah, you hear all kinds of stories, but there are people that actually go out and try to track them down. Because if you can track it going up and you know where it popped, you can probably find out a general idea where it would be. So it's probably, most of them will probably end up in woods somewhere or out in the lakes. Yeah, sir.
In the past, I've had interest in thermals and turbulence, and I see occasionally, I guess, physics journals talking about using LiDAR. Is LiDAR a way to image different air densities, or what can you tell about LiDAR, what that's about?
Well, let me just, so the radars that they're using now are using microwaves. So I've heard a few cases where they've used
It's laser?
lasers or
Okay.
correlation spectrometers kind of thing, where they would look at certain frequencies
Okay.
in the atmosphere. I think that they're experimental in
Yeah.
some cases, and in other cases, to be honest with you, I don't have that much experience with it. I know there's been some cases where, when I was working with DTE, we had talked about renting something like that. So you could at least get an idea of what's going on above a certain point.
Mhm.
And some of that was LiDAR technology.
Okay.
And then it comes down to, well, what do you do to ingest that information and digest it and share that information?
Okay.
So,
Is that the kind of thing that NASA would be doing, or is that?
I think so, yeah. I mean, I think it's a little bit more expensive.
Mhm.
I don't think they're gonna go out and put, LiDARs across the country kind of
Right,
thing.
yeah.
But, I may be wrong, but I think they actually use them around the Cape Kennedy and
Oh,
such.
okay.
To get an idea of what's going on in and around there, because if you're setting up a payload,
Oh, yeah.
you don't wanna turn around and put it in jeopardy if there's some wind shear out there.
You said that NOAA was like the best weather service. Where do they get all their data from? I mean, does NOAA own the data gathering equipment, or do they like contract out to all the locals where there is weather gathering equipment? Yeah, I mean, there
Yes.
has to be a heck of a lot of
There
equipment
is.
out there.
Yes, there is, because if you look at thousands of places across the country, airports and such. Let's see. So I don't have a good graphic on that, but, so the National Weather Service, I'll come back.
Just looking for all of the airport reports and stuff.
Yeah,
You have the Aviation Weather Center one open.
oh, okay.
Go to the observations, under weather, over
Oh, okay.
observations. Click on it. There's
There
all
we
the-
go.
As you zoom in, you can see all the weather reporting stations.
Okay, so obviously the airports, are gonna need to have, the observations. Because you wanna have that altimeter setting, taking off and landing kind of thing. So that's essentially all funded by the FAA. So I'll just give you one little story here. They used to make them all, observations were made by hand. Well, not by hand, but by human observers. So then they said that, okay, FAA says, well, we're gonna pay for this now. We wanna automate everything. So that's when they put in automated systems. So out here at Metro Airport, they put in the automated system. Well, there's two things that the automated system didn't do. It didn't give you snowfall, because the observer did that. And it also didn't give you clouds below 20,000 feet, I think it was. So technically, for 1 year, Detroit did not have any snowfall. Why? Because there wasn't an observer to do it. It wasn't until the following year they funded it to turn around, we'll supplement that information with a human observer. Certain airports supplement their weather information with a human observer. Well, then all that information from all these different locations feeds into the National Weather Service, where they go through and say, okay, this is good, this is not good, and put it into the format so they can put it into all their models. So yeah, there's a lot of data that goes out there. It's all free and available to us to see, for our own particular, reasons for flying or whatever. But there is, it's a humongous amount of information. Yeah.
You had one screen up there where it showed mountains and no data.
Right.
Why would there be no data for, what was the particular data that was on the rest of?
Well, so the rest of it is the winds.
Okay,
Okay, so if the winds are at 5,000 feet, and this is either based on the observations that we were just talking about, or it was based on a computer modeling run, well, there would be no data because, an example, Pikes Peak, I think, is at, 10,000 feet? Maybe somebody knows.
okay,
So you can't have data inside the mountain
yeah,
because there is no data.
okay,
So that's why there's gaps. So then the models and the forecasters have to take on all that kind of stuff because there's no data there. So as you go up higher in altitude, there's more data, but then you go below a certain point, there is no data. So it's one of the little problems that we have with having to deal with the data. Just like we don't have data out in the middle of an ocean. Well, it's assumed, or it's monitored by a satellite, or maybe there's a buoy out there that's giving us a piece of information. I think in Lake Michigan, NOAA puts out in the springtime, it's, I think, 2 or 3 buoys. Well, that's an awfully big lake. to just represent with 2 or 3 data points. So, yeah, but no, that's one of the problems that we have with meteorology and weather, and that's that data kind of thing, so, yeah. So, go ahead, here.
What's generally a transition from a watch condition to a warning? Is a warning by radar and by spotter that say this is a warning and something's been sighted? Or is it radar attributes that you're determining it's not just a watch, now it's a warning? So,
Right, okay, so. So the National Weather Service Storm Prediction Center will send out several times during the day what they would call a convective outlook. That's just an area where they might expect convection, maybe some thunderstorms. Then they may say, okay, there's a general risk or a slight risk of some severe weather. So they are then responsible to say, okay, there's something going on the ground, looking at the radar, looking at the satellite. Then they will issue a watch and give a specific geography boundaries for the watch. Then they basically turn it over to the National Weather Service local office that may be in that watch area. Then up to them to monitor the radar, look at spotter information, looking at police and fire information kind of thing, and actually issue a warning for a particular area. So they try to issue them for counties or parts of counties. So the hierarchy is basically Storm Prediction Center, watch, and then warning, and then warnings are done locally. Yeah. That's probably the one big thing, because there's so many people out there that talk in the weather, whether it be Facebook, Twitter, apps here and there. Everybody says, oh, this is going to happen. But in most cases, they're reiterating or parroting what's already been put out there by the National Weather Service. And I'm not saying that there's not meteorologists that know something going on, but I hate to say it, a lot of them are out there for clicks. They're out there looking for people to, look at what's going on. I had an opportunity to go to take a tour of the Weather Channel years ago, and down in Atlanta, Georgia, and they had this graph on one of their bulletin boards of viewers. Well, hurricane was going through, and I don't remember what hurricane it was, but you could see it was going up as the storm was coming in, and then as the storm was going away, the viewership went down. So what are they doing? They're trying to get people to view, to sell advertising for whomever is advertising, and make a few dollars in the process. So, and another little story along those lines, I went to another national conference. I got on the wrong bus back to the hotel. Well, maybe it was the right bus, because that particular bus happened to be the president of the Weather Channel. And he was talking about how a particular storm was going up the East Coast. And the new computer models came out and said, okay, it's not going to hit Washington, D.C. But what they did, and I find this very unethical, told their on-air people to turn around and say, the storm is going to continue to hit the area in the next couple hours. But in reality, the new model runs say it's going to miss the area. So that bothered me, because people are making decisions, either for travel, daycare, food, all that kind of stuff, based on old information. And maybe it was not the best information, but I just had a hard time with that kind of thing, because then it's about the dollars and cents, advertising and viewership and that kind of thing. So that's just my personal opinion on things. Take it from there. But yes, I'm sorry.
Turbulence, is that primarily based on what aircraft report back, or do models have input into predicting turbulence?
So yeah, so on the turbulence side of things, I think even the aviation weather, think there was actually
There is.
turbulence.
right under there.
Yep. So some of it's based on, reports back. Some of it's based on predictions going forward. Obviously, the best predictions are gonna be the ones that are shortest fused, because they're gonna be more current, and the models are probably more current at that point in time.
So, I mean, looking at that, those boxed areas are basically model information. You see the blue, yellow, green dots? Those are actual individual pilot reports. So you're seeing both on this graph.
Right. Yeah, so the symbols are gonna be
Those are reports.
reports, and then they be characterized based on the severity of that report. And obviously, if they're falling in certain boxes, there'd be verification of predictions. And, maybe they have to change something on the predictions as well. Okay, so let me, so, Storm Prediction Center, we'll talk about what's going on today. This is their main page. And so their convective outlooks, now this was updated, valid to tomorrow morning. Issued at 1957Z, so it's a few hours old. So these are the areas that they are looking at to have these various levels of severe weather, or have the potential for. I can't, reiterate that more. It's like, it's the potential. It doesn't mean that these areas need to be evacuated or anything else like that. So these are the areas in the red boxes are watches. The red ones here are tornado watches. So there's obviously nothing in Michigan going on, but these are, again, issued by the Storm Prediction Center. This MD stands for mesoscale discussions. These are areas that, so they'll look at the weather, say there's a watch. Well, before the watch, they may turn around and say, let's talk about the weather a little bit. So the mesoscale discussion, let's take a look at what they say from Michigan, since we're in Michigan. So they would have some text that will go along with this. Increase in thunderstorm coverage expected over the next few hours. Primary concern is severe hail, though locally damaging winds are also possible. So what I see on this as a meteorologist is I see that red barbed area down to our south, that's the warm front. That's where we should have seen the warm temperatures today. It obviously didn't make it into Michigan as of this point in time. So what that tells me is that the warmer areas are where you have the most intense instability, most intense convection going on. Best chances for severe weather. That's one of the reasons why they had a tornado watch in Indiana and not for Michigan. So it looks like in this case that a little bit of cooler temperatures, and if you look at the wind barbs, maybe the whole system aloft is moving off to the east or northeast, but at the surface, the winds are coming out of Canada, out of the east. So it's keeping that cool air coming into the area. So that will cut down on any surface-based instability, so that aloft, we may see the rain moving in, but we may see more heavy rain. And at least based on my point of view, that's why they end up saying, okay, there's a possibility of severe hail in this whole area, but the best locations are going to be in the southern areas where it's closer to warmer air. Now, you can get some small hail by just getting that upwards and downwards, vertical motion, where you get that raindrop, goes up above, freezes, falls down. Oh, it's still not going to reach the ground. It's going to go back up and be a little bit bigger. that's where you would get the, the chance of hail out of that. Damaging winds are always something they're gonna turn around and say, otherwise it probably wouldn't be severe weather. And then hail is gonna be more localized. Tornadoes, they're not even mentioning that in this discussion. Then if I slide down. Summary. Thunderstorms should increase in coverage across portions of lower Michigan during the next few hours. The primary concern would be isolated severe hail, though locally damaging wind gusts cannot be ruled out. And then obviously got a little more details here. Am I?
Well, maybe like 5 more minutes.
Okay, I was gonna say.
Don't look at that clock. That clock's not right.
Oh.
Clock is incorrect.
All right, so one of the things I do like to look a lot at is the satellite imagery. This is kind of cool this time of year because that line that you see between night and day is almost vertical. In the summertime, it kind of shifts more towards like 24-hour sun in Alaska, and then wintertime it's like 24-hour dark in Alaska. But you can see a lot of things going on the satellite. And let me just see if I can. Great Lakes. So this is great during the daytime, but then you say, well, at nighttime, what do? You can't see anything. So then they end up switching things over to either water vapor or infrared.
How come there's so many infrareds?
Same reason that there are so many other water vapors and such. They end up going through, and the satellites are a lot more sensitive than just looking at a picture. They look at certain frequencies of light. I mean, fluorescent may pick off a certain point. Well, the satellites go through and pick off little bit different frequencies that may be higher, lower elevation, maybe more based on water vapor in the air. This is basically showing, a lot of clouds coming in, and then you can tell by looking at, okay, is that cloud level warming, cooling? This yellow back in here, is probably some drier air back up in the UP, and then obviously down here you're seeing a lot of rain moving in. So, just to kind of finish things up here before I get kicked out.
No. This is super cool though. I'm gonna have you send these links to me.
we can do something, put them on a web page or whatever. So one page I like to look at is the College of DuPage, and they have a bunch of different weather models. So instead of looking at just one model, we can look at the short-range models, which is like the one over here, the HER I was looking at, and then we also have the longer-range models that go out 10 days or so. So this is showing that it's incomplete data, so let me go back and look at the previous hour. Okay, so this is a prediction of what the radar should be looking at as of 8 o'clock today. Well, it's a little after 8. So let's look out and take the scroller and move out a little bit further. Okay, so this would be a couple hours. So obviously we see that area to our southwest moving up this direction. Is this tornado weather? No. We just looked at the mesoscale discussion. Says, heavy rain, maybe a little bit of hail if there's something going on. And then, and over the night, okay, this will be like close to midnight. See the whole pattern shift from west to east. Area down to the south, obviously they're having a little bit heavier weather than we are. And then there may be a couple little bands of some showers that come through closer to morning. So by sunrise or so, there may be a shower or so. And then clears out. Then you just have to watch and see if there's another little wave that's gonna come by on that front and, you know, bring in some more clouds and, but the last thing I looked at, again, from the National Weather Service. Excuse me as I fly around here. Okay, Detroit. Okay, so this is the local office for Detroit. This is their webpage. And the green areas there are a possibility of some flash flood watches. The orange areas are tornado warning, or not tornado, excuse me, severe thunderstorm warnings based on what the radar was picking up. Doesn't mean that what you see out in cold water is coming this way. It doesn't mean that it's, you know, based on what we had seen on and the fact that there was no watch for our area, and the fact that they were saying heavy rain and maybe some hail, that may not even translate into our area. But what I do like looking at from the National Weather Service, let me just pick Ann Arbor, they will break it up into a little bit smaller area. And what I used a lot when I was working was people wanted to know what's going to happen when. Okay, so here's an hourly breakdown. And I can go out six days with this if I wanted to. So what this is showing is, okay, hey, we may get up to 62 here by 11 o'clock tonight. And then tomorrow, it's going to cool down just a little bit to 60, and then by tomorrow night, down to the 40s. And by Friday morning, 40. But as you can kind of see in the green, that's the green bars, or the rain, and the heaviest rain is going to be yet this evening. And then it'll taper off to some showers, and then by sunrise, it looks like the rain should be done. And you see probability of precipitation. You can see the winds. You know, the winds are out of the southwest, and then switching around to the west. You know, like in, yeah. And the temperatures, and then you see the dew point in there too. So that's, I like looking at this. I can be a little bit more specific, a little bit more, you know. Granted, it's not 100% accurate, but at least I can be a little bit more, you know, truthful about some of the stuff that's going on.
How often is the National Weather Service updating this info for Ann Arbor in this case?
I think it's every couple of hours, because if there's something going on, they would end up making some corrections in there as well. Oops. Okay, so we talked about severe weather a little bit. We talked a little bit about the National Weather Service. The National Weather Service breaks up the whole country into little areas that have areas of responsibility. Detroit, White Lake office covers everything from the thumb to Ohio, and then out to Lansing, almost to Lansing. And you can look at the whole United States and pick out a particular area and see what's going to be going on there, or if there's watches or warnings going on in those areas. Last questions for anybody? Something is just on your mind. You got to ask that question.
So does Gaylord cover the rest of Michigan?
So the Weather Service. So okay, so there's southeastern Michigan. You go to the west and you capture Grand Rapids, and you get the counties southwestern Michigan. You go further north, and that's where the Gaylord office covers. And then if you go northwest, you'll get the Upper Peninsula. So they've got, what's that, 4 different areas across the state that they've broken it up by counties. So they all have their own responsibilities, you know, as far as this county. And they report back, you know, they're always looking for spotter reports. It's like pictures of something. They were asking about the storms that came through here the other day. Did anybody have any pictures? Because they also like to go through and say, okay, we predicted this storm and we had observed this storm. And they come up with like a false alarm ratio or how accurate their warnings are.
Was there some, I don't want to say accuracy or ability to predict how bad that icing storm was up north? I mean, as a power company, are you forecasting, say, oh, this is going to be a bad one, or you, I mean, how accurate or what kind of information you get?
They had a pretty good idea, because this is like the second or third wave that kind of came through, because I happened to be up in Escanaba the week before, and they had snow go through, and then they had another storm that came through afterwards, and that kind of kept things cold up there. So they had some pretty good ideas that there was going to be icing. The question is, again, is how much? And that's where you like to get the spotter reports coming back. But I did see, photographs of, like a ½ inch to an inch of ice, which sounded very similar to me, because back in 1998, there was an ice storm that happened up in Quebec, in Montreal, where they're in a valley, and they had multiple days of moisture moving over that valley. Well, it stayed cold down there. They had inches of ice, brought down transmission towers, and people were out of power for, I don't know, weeks. And they were bringing in linemen from across the country. They flew some people in from Hawaii even, just to help out to restore and rebuild. So, yeah, sometimes the conditions set up in and around the lakes. If the lakes are cold, like they were this time of year, they're keeping that cold air in, and then you're bringing in the warm air aloft, and the precipitation falls and freezes on contact. So, yeah.
I noticed on TV somewhere, just earlier today, they had radio tower, Petoskey came down.
Oh, I saw that.
It's like, well, so that's quite a ice load, I guess.
Yeah, because you can add hundreds of pounds just due to the ice, whether it be to branches,
Yeah.
power lines, and transmission towers, radio towers. So yeah, so that's another reason why it's like you want to be able to go make sure you got newer, stronger poles, towers, and that kind of stuff to handle that kind of thing. So, yeah.
All right.
Okay.
Well, excellent. That was great. Thank you. Thank you so much for doing that, though.
Oh, you're welcome. You're welcome.
I have a couple little things to chat about before I officially release you all.
You're passing out the quiz?
Not quite. Thank you again. So, again, don't forget, you can leave it up, that's fine. Don't forget that we have these programs every first Wednesday of the month. Next month in May, we're going to be having the president and CEO of the Tuskegee Airmen National Museum, Brian Smith. He'll be coming out here to talk about the Tuskegee Airmen, and we'll be selling the book Soaring to Glory in the gift shop. So I highly recommend coming out for that. The tickets will officially be available on the website starting tomorrow. So as you all probably know, a lot of these are made available on the website about a month or so prior to the event. Again, Bombers, Berries, and Brews is coming up this weekend. We still have tickets available. They probably won't be available for much longer. So if you would like to come, we'd love to see you. Just go on our event website, and we'd love to see you on Saturday. One last thing, don't forget about the donation boxes. If you're able to donate, we really appreciate any support that you're able to give us. We have one over here in the corner or along the wall, and then one in the hallway as well. If you ever have any questions about the museum, about membership, members can reserve tickets for these events for free. So I'm more than happy to answer questions about that, about membership, about the museum, our upcoming events, and more. So thank you so much, and I hope you have a safe drive home.
Thank you.